Hey, hi and welcome back. So in this video and in next video, we are going to discuss everything about resistors. Okay. So after completing this video and next video, you will be very much confident about resistors. And if someone asks you anything about resistors, then I can assure you will be able to answer all his questions. Okay. So let's start with this video now. So before we start with this video, let me tell you what you will learn in this video. So you will learn what is resistor and what's the purpose of resistor in the electronic circuit. After that, we will see what are the different types of resistors available in market. So this is how basically we are going to cover this video, and I hope you will enjoy this video. Alright, so let's start with this video now. So I am sure you know what is resistor. So I will not emphasize more on the definition of resistor. Rather, I will focus on the important things about resistor, that will actually help you while designing the circuit. Okay. But quickly, if I have to give you a formal definition of resistor, then it's basically a passive two-terminal electrical component that implements electrical resistance as a circuit element. Okay. So that's basically the definition from the Wikipedia, which actually tells the main function of resistor is to provide the resistance in the electrical circuit. Okay. Now let me explain you what's the purpose or the application of resistor in the electrical circuit. So the first purpose of the resistor is to limit the amount of current flowing through the circuit or the branch of the circuit. So let me explain this point now. So this is basically the circuit, and in this circuit, this resistor is actually responsible for controlling the amount of current which will flow through this circuit. Okay. So by adjusting the value of this particular resistor, we can actually limit the amount of current which will flow through this circuit, and based on that, we can actually control the intensity of this LED. Okay. So that's basically the first example. Now let me give you one more example. Now in this circuit, if you see, there are actually two branches. Okay. So in first branch, this resistor R1 is connected, and in second branch, this resistor R2 is connected. Okay. So based on the value of this particular resistor R1 and based on the value of this resistor R2, it will be decided how much current will flow through this particular branch. Okay. So this resistor R1 and this resistor R2 is actually limiting the amount of current which will flow towards this LED. Okay. And based on the value of resistor that you will use in this particular branch, it will be decided what will be the intensity of this LED. Okay. So I hope that this particular point is now clear to you. After that, the second purpose is to drop the voltage or to achieve a desired voltage in the circuit. Now let me explain this particular point. Now in this circuit, if you see, this resistor R1 and this resistor R2 is actually responsible for dropping the voltage. Okay. And on the input side, if you see, the voltage is actually the 5 volt. Now based on the value of the resistor R1 and based on the value of resistor R2, it will be decided how much voltage you will get on the output side or at this point with respect to this point. Okay. So here this resistor R1 and R2 is actually responsible for dropping the voltage. So the 5 volt that you see here, some voltage of this 5 volt will actually drop across this resistor R1 and some voltage will actually drop across this resistor R2. Now where you will use this particular circuitry? In op-amp, you have to actually provide the reference voltage. Okay. And that reference voltage actually it can be any value based on the application that you are dealing with. And in that case, we actually set the reference voltage by using the suitable combination of resistor. Okay. For example, let's say that if you want 2.5 volt on the output side, then based on the value of resistor R1 and R2 that you select, you can actually achieve a 2.5 volt on the output side. For example, if you select R1 as 10 kilo ohms and if you select R2 as 10 kilo ohms, then this combination is actually going to give you a 2.5 volt on the output side. Okay, so 2.5 volt will actually drop across this resistor and 2.5 volt will actually drop across this resistor R2. So based on the value of resistor that you will select here and based on the value of resistor that you will select here, you can actually achieve a desired voltage at this point. So that's all about this particular circuit. Now let's consider one more circuit, and this circuit is actually similar to this circuit. Now let's consider that there is one 5 volt device, and this 5 volt device is actually generating a square wave whose amplitude is 5 volt. Okay, so this is 0 volt and this is 5 volt. And there is another circuit on the output side, and this circuit actually works on 3.3 volt. Okay, so if we provide 5 volt directly to 3.3 volt, then this particular circuit will actually get damaged. Okay, so with the help of resistor combination or by dropping the appropriate voltage across the resistors, we can actually achieve a 3.3 volt on the output side. Okay, so we provided 5 volt on the input side, a 5 volt signal, and we got the 3.3 volt signal on the output side. Okay, so this is how basically by choosing the appropriate value of resistor, we can achieve the desired voltage on the output side. So that's basically the second purpose of resistor, which is to drop the voltage across resistor and to achieve the desired voltage using the proper combination of resistor. So that was all about the purpose of using the resistor in the circuit. Now let me show you the different types of resistor. So the resistors are actually, mainly classified in two types. The first one is through-hole resistor and the second one is SMD resistor, okay, which actually stands for surface mount device. So depending on your application requirement, you can select one of the type. For example, if you have a size constraint and if you want to make your device compact, then in that case, you should go for SMD resistor. Okay, otherwise you can go with the through-hole resistor. And from price point of view, if you see, both of them have the similar price. But as you know, in case of through-hole resistor, as its size is big, so, it's obvious that it's going to take more space on the PCB. Okay. And if we consider space as an aspect, and from that point, if we think, then through-hole resistors are actually more expensive because that takes more space on the PCB, which will result into larger size of PCB and as a result increase in price. Okay, so through-hole resistor actually, indirectly it increases the price of the product. Okay, and in our case, the hardware that we are going to design, it actually includes all the SMD resistors. And I have selected SMD resistors, not just because I wanted to make the device or the circuitry or hardware compact, but also because I had them in stock. Okay, so that was actually the main reason for selecting the SMD resistor. Now let me talk about the packaging or the way you will receive the resistors when you order them. Okay, so this is how basically you are going to receive the through-hole resistor when you order them, or if you go to the local shop and if you want to purchase the through-hole resistors, then this is how basically the vendor is going to provide you the through-hole resistors. Okay, so you can remove one resistor or multiple resistors based on your requirement, and you can use that through-hole resistor in your circuitry. Okay, and later based on based on the required length, you can use that much length, and rest of the length you can actually scrap with the help of cutter. So that's basically the through-hole resistors, and this is how you are going to receive the through-hole resistor if you purchase it from the market. After that, this is how basically you are going to receive the SMD resistors, and this is actually called as cut tape. Now why it is called as cut tape, you will get that in a moment. But this is how, for example, if you order 20 quantity or if you order 30 quantity of SMD resistor, let's say 10 kilo ohms, then this is how you are going to receive the SMD resistor. And there will be actually a plastic film on top of this tape. So you just have to remove this plastic film, and based on the requirement, you can actually take the SMD resistors from this tape. Now why it is called as tape? So let me discuss that particular point. When the manufacturer produces the resistors or any other component like resistor, capacitor, inductor, then it's actually going to be in the form of reel. Okay, so this is actually called as reel, and the manufacturer is actually going to produce these reels in the quantity of 2500 or 5000 or 10,000. So it's going to produce these reels in that much quantity. Now, we generally don't need this much amount of resistors as an individual. So what generally manufacturer does, they are actually going to sell these reels to, to the authorized distributors, and they are just going to cut the reel based on the requirement, and then they are going to sell that much amount of components. Okay, so that's basically called as cut tape. Okay, so this is the entire reel, and once you make a cut in this reel, then that basically forms a cut tape. Okay, so depending on the requirement, depending on your application's requirement, you can order as many number of components. Okay, but the companies actually require this much quantity if they have that kind of product. For example, I used to work on a product where we used to order the components like resistor, capacitor with a quantity of 10,000. Some companies, they are actually going to order the resistors and capacitors in the form of reel. But as an individual, as we don't need that many components or that much quantity, so we generally order these resistors and capacitors in the form of cut tape. Okay, so I hope that it's clear now. Alright, so that was the first part about resistor, and I hope that you enjoyed the first part and you learned something valuable. Okay, so that's what I wanted to tell in this video. Now I will see you in the second part of this video, which is Introduction to Resistor Part 2.